All right, let's get right into it. If you're gearing up for your AWS Solutions Architect exam, you already know containerization is a huge deal. So today, we're going to zero in on one of the most important services in that space, Amazon's Elastic Container Service, or ECS. Let's unpack this thing. So right off the bat, here's the official definition from AWS. Now, the words you really want to latch onto here are highly scalable and management service. See, ECS is all about running your containers without you having to manually figure out where they should go or what to do when they fail. It's the control plane, the brain, that does all that heavy lifting for you. And here's our game plan. We'll kick things off with the why, the big picture. Then we'll dig into the what by looking at the core building blocks. After that, we're going to tackle the two biggest decisions you have to make, your launch type and your networking mode. And of course, we'll wrap it all up with some rapid-fire quick hits you've got to know for the exam. Okay, so first things first. Before we get into all the technical details and the how, we really need to understand the why. I mean, what problem is ECS actually trying to solve? Why does this service even exist in the first place? And here's the absolute heart of it. Look, running one single container on your laptop, that's easy. But running hundreds, maybe thousands of containers in production, making sure they're healthy, replacing the ones that fail, connecting them all securely, well, that gets incredibly complicated incredibly fast. ECS is the orchestrator that takes on all that complexity for you. It's all about abstracting away the management headaches so you can just focus on building your app. So, to really get a handle on ECS, you have to know its fundamental pieces. I like to think of them as Lego bricks. You're going to use these to build any application you can dream of on the platform. And for your exam, knowing how these pieces snap together, yeah, that's completely non-negotiable. Everything, and I mean everything, starts right here with the container image. This is your master blueprint. It's a totally self-contained, static little package. It's got your code, the runtime, all the system tools, every single library, literally everything your app needs to run. The whole point is to make it a perfect, unchangeable snapshot. Now, what's so great about this diagram is how simple it makes the entire container lifecycle look. You build the image from your code, then you store that image in a registry. On AWS, that's called ECR, the Elastic Container Registry. And finally, you tell ECS to go run it on some compute power. That's it. Build, store, run. It's a beautifully simple, powerful, and totally repeatable workflow. So if the image is the blueprint for your application itself, then the task definition, well, that's the blueprint for how to run it. It's basically a JSON file that tells ECS all the important details. Which exact image should I pull? How much CPU and memory does it need? What IAM role does it need to talk to other AWS services? All those questions get answered right here in the task definition. And this right here beautifully lays out the entire CI/CD best practice. Just follow the arrows. A developer pushes a single commit to Git. That specific commit triggers a build for unique container image with a matching tag. Then, that unique image gets referenced in a brand new, unchangeable revision of a task definition. This one-to-one-to-one mapping, that is the absolute key to having reliable, traceable, and repeatable deployments. This is how you do it in production, and it's a concept you'll definitely see on the exam. Okay, so you've got your task definition. It knows what to run and how to run it. But now for the million-dollar question. Where do you actually run it? This brings us to the most fundamental architectural choice you'll make with ECS. And believe me, it's a super common exam scenario. Are you going with EC2 or are you going with Fargate? Let's just break this trade-off down. It's actually pretty simple. With the EC2 launch type, you're in charge of the servers. You manage the whole fleet of EC2 instances that your containers run on. This gives you ultimate control, right? You can pick specific instance types, handle patching, fine-tune everything. Then there's Fargate. Fargate is serverless. You just hand your container over to ECS, and AWS magically finds the compute power and manages it for you. So here's the bottom line. You choose EC2 when you need control. You choose Fargate when you want simplicity. Next up, networking. And this is a topic that can seriously make or break your whole architecture's security and performance. How do your containers talk to each other? How do they talk to the outside world? Let's walk through the options because they build on each other, from pretty simple to really sophisticated. So ECS gives you three main networking modes. You've got host mode, which is the most basic. It just sticks the container right onto the host network. Then you have bridge mode, which creates a little virtual network inside the host. But the one you really need to focus on, the star of the show, is AWS VPC mode. This is the one that gives every single task its own dedicated network interface. So here's host mode in action. You can see the container is mapped directly to port 3000 on the EC2 instance's main IP address. So what's the big problem with that? Well, what happens when you want to run a second copy of that container on the same machine? You can't. Port 3000 is already taken. It's a huge scaling limitation, which is why you almost never see this used in the wild. Bridge mode comes along to solve that exact problem. It uses a clever little virtual network bridge to map some random high-numbered port on the host to your container's port 3000. And just like that, you can now run multiple copies on the same EC2 instance. It's definitely better. But all the tasks on that host are still sharing the same network security context, which isn't exactly ideal. And that finally brings us to AWS VPC mode. This is the gold standard, the recommended approach. And, by the way, it's the only mode you can use with Fargate. Each task gets its very own Elastic Network Interface, or ENI, and its own private IP address. It's basically treated like a first-class citizen in your VPC, just like an EC2 instance. This gives you the absolute best security and network isolation, period. Hey, don't just take my word for it. AWS's own best practice guide says it loud and clear. The ability to assign a unique security group directly to a single task is a game changer for security. It means you can create these super fine-grained firewall rules. Like you can say, my order service is allowed to talk to the database, but my authentication service is blocked. For the exam, if a question involves security and networking, AWS VPC is almost always going to be the right answer. Okay, we have covered a ton of ground. So let's boil all of this down into the most critical, most important points you need to lock in for your Solutions Architect exam. Think of this as your last-minute cheat sheet. Okay, you ready? Here are the 5 things you absolutely have to remember. Number 1, for networking, your default answer is AWS VPC mode. Why? Superior security. Number 2, for compute, start with Fargate. Why? Simplicity. Only go to EC2 if the question specifically calls out a need for instance-level control. 3, isolate your microservices. Each service gets its own task definition and its own least privilege IAM role. 4, keep your images small. Use multi-stage builds so they start up way faster when you need to scale. And 5, tag everything. Seriously, it's so important for tracking costs and just keeping your environment organized. So to wrap this all up, I'll leave you with a classic exam-style question to chew on. Now that you know all the building blocks, how would you put them together to build something that's cost-effective, highly available, and can handle totally unpredictable traffic spikes? Think about it. You'd probably combine Fargate for serverless compute, AWS VPC mode for secure networking, and then throw in some service autoscaling. That's really where all these concepts come together to build some incredibly powerful stuff. Thanks so much for tuning in.